In this video, we take a look at Visual Studio, how it organizes C++ code, how we build and run our applications. Most of what I'm going to say here I have already said in writing in the first assignment's handout, but there might be a couple of new things in here also. So Visual Studio is pretty much the best C++ development environment on Windows. Certainly the most used. And it has finally received good support for C++ 11. Earlier, Visual Studio's built-in compiler was lagging severely behind in C++ support, and the open source GCC and CLang compilers were doing a lot better. They are still a bit ahead of Visual Studio's compiler, but not as much. So Microsoft's recent push towards modern C++ and supporting C++ is really showing. Visual Studio is particularly known for having a good debugger, and in a later video we'll look at how to use the debugger in more detail. The way Visual Studio organizes things is that you always have one solution open, and solutions are much like workspaces. A solution can contain several projects, and each project either builds into an executable program or it is built into a library which is then included in a program as a component. Going into Visual Studio, here we have the first assignment open, and on the left we can see the two projects in the assignment solution. The lower one is called Framework, and this is the library from NVIDIA Research that contains all kinds of useful stuff for graphics, for math, and you'll mostly be looking at the math side of things from here. It's built into a library, and then that library is used by this other project, Assignment, which is built into an actual executable program. So if we want to build and run this, we go to the Build menu, we can choose Build Solution, and then we wait a while. The rest of the builds after the first one will not take as long, because all the byproducts of the build will be there. And for instance, the framework library will never have to be rebuilt if you don't make any changes inside it, which you probably shouldn't. So we have everything built, it succeeded. So now we probably have an executable we can run. So we go to the debug menu and we say start without debugging. And here's assignment number 1 as a working application. Note how we have the window here with the OpenGL graphical output, and then in the back we have a console window. This is also a part of our assignment application, and in this console window you can actually print things. And the frame rates are now in the region of 800 FPS. That's a lot, but we only have a couple of triangles here, so it should be a lot. And I'm going to close this down. Then here we have configurations. So these are essentially build configurations. How are we going to build our program? And we have two choices. We have debug and we have release. So let's try it out. Now I want release, and I'll have to build again. Now it's going to do all the work because it can't use the build byproducts that were cached for the debug build. Everything's built again and we run. Again, start without debugging. And we are now seeing slightly higher FPS, around 1000 on my machine. So there's a performance difference visible, but when we have more substantial applications, the difference will become much greater. So we'll close this down and consider our build configuration choices for a bit. So the debug build does a lot of extra checking. It includes info in the build that the debugger needs if you want to look at program behavior in real time. And it's a lot better at catching bugs because it doesn't cut any corners. It's slow, sometimes unusably so, and it does not reliably predict programs' actual performance. So the amount of slowness you get from running in a debug build is not always proportional to the speed of the release build. And the release build has various compiler optimizations turned on, and it can be sometimes 100 times faster than a debug build. And because it doesn't do any kind of safety checks that it doesn't have to do, it will often run your code even if you have bad bugs and even if a debug build built with the same code would crash. It's also possible in C++, but much more rare, that the debug build masks a bug that you have written. But all in all, both of the builds should always run and compile. If either one of them crashes, then the fault is generally in your code. So you should look for the problem and try to catch it. And the fact that your program runs in one build mode but crashes in another is itself a symptom that can be used to track down the problem. And we can take a quick look inside and check out what this project contains. We have a couple of source files, 3 source files in the base package containing the actual C++ code. The NVIDIA library has a lot more files and folders, and fortunately the Visual Studio built-in build system handles building all of these for us, and you generally don't need to care about how that happens. You just select build solution in assignment. But later I will explain a bit about the C++ compilation model, because you may write code that causes so-called linker errors, and then knowing what a linker error is will help you fix your bugs. In the next video we'll do some live coding and actually start putting together C++ code. We'll write a simple program, do some basic operations, and see how the standard libraries are used and how you can find functionality that you need from a standard library